Good. So, okay. That's a, we're doing subtracting. But we're going to add actually. This is the method represent. So now add this to number and let's try this test calculator, right? Your main method, we're executing. And now we have calculator, cal, of course has to be caps. Oh, so now cal dot add to number, right? And the to number would be 10 and maybe 8, right? Now these two numbers need to be added and stored into a variable called result. Once it's stored, then we need to verify if that method was returning the right value or not. So if you import assert maybe. Alright, let's take a look here. JUnit API. So this is the API for JUnit framework that you can explore. And to import that, you can import all.JUnit. It has test before class, before after class, and it also has assert. So we are going to use the assert class now. So assert class are verifying the expected and actual values. So to use this, you have to import all.JUnit.assert, right? Why is it not popping up? Is it not part of this? All.JUnit. All right. Okay, so maybe you can download that. JUnit jar download. So we have JUnit here. This is jar file we need. So copy this, and in Eclipse we have to let's create a new leaf folder called library. In the library, paste it here. Wait, paste it. So JUnit, we can download it. Later on, once you start Maven, we'll see that how we can manage dependencies by another tool. But right now, we're just doing manually download it and use it in your project. So create a lib folder and whatever dependency you have. So in this project, dependency is JUnit. And once you put it in the lib folder, next thing you have to do is you have to build path. The way to do it is right click on the project, properties, and Java build path. Then go to the library, then say add jars, and expand the project, expand the lib folder, this is library folder, say JUnit, say OK, and hit. So now JUnit become part of your project. If you don't create a lib folder, if you simply say right click and build path, and if you say don't add jar but say add external jar, in that case you could just go simply to download folder and add this. So now what happened is it's pointing to the C drive on your machine. But later on we have a problem that right now this JUnit is part of your project. Wherever the source code goes, the entire project goes, your dependency goes. But if you point to your dependency to a C drive or D drive, then and you try to run in different machine and it doesn't find the dependency, it's a problem. The safe way to do it, better way to do it, create a lib folder called library folder. All the dependency you have, put it here, and build path and say, hey, point to this. Instead of saying add external jar, you say add jars. So anywhere project goes, it will carry the lib folder and dependencies. So it's better to point to add jars, not external jars. Clear? Okay. So once you have this lib folder and which has jar file, it's part of this project. Now inside this class, we can see org.junit, right? Before we didn't see JUnit framework part of this project. Now since we have jar files, our build path is there. Within the class path is JUnit is there. Now you can import those classes. Before we didn't see that JUnit framework. Now you can see that it's all about JUnit framework. Right? So org.junit.assert. We're interested about assert class. So where is the assert class? Yeah. Right? Now you can see it's imported properly. Now you can call that method. Instead of saying assert equals new assert, we could say simply assert equals, is because assert equals is a static method. So you don't have to say new that method name. Rather you could say class name dot method name because that method is static. So assert equal all right, let's type that. This is the problem with it's not a problem, but more convenient in IntelliJ. So assert equals. So what do we need? Framework is offering many options, comparing array to array, object to object, string to string. But what we are comparing is integer to integer, right? It's because the result is getting integer value, and we want to compare it with another integer value. So let's look for one that accepts two integer. This is look like array. So let's go for only integer to integer. Do you see anywhere? Alright, even though you just hit one and it will it will accept, hopefully, don't say array. Oh, it's duplicated one. All right, so and we are saying 10 plus 8 should be 18, right? So what we are saying, this line here, SR.SR equals, we're saying whatever, not the entire unit duplicated, this few method probably. So SR.SR equals result is we're expecting from this method. 10 plus 8 should be 18. So result should be 18. If 18 and 18 match, that means it's been tested and verified. No error will be thrown, whether say pass. But if result get other than 18, then it's error. That means this method didn't work. Something went wrong. So let's run it. You can see that main assertion expected 2 but was 18. Expected 18. Expected 2 but was 18. Okay. Let's do other way around. 18 and this is yeah. So this should switch. So this is the one expected but and didn't happen. So you're saying expected 18 but was 2. So we know this add method, add number means you're going to add two number. We pass 10 plus, we pass 10 and 8, and since this method will do addition, which is 10 plus 8 should be 18, and this is what we're expecting, 18. But result was 2. So something went wrong. So this is the unit test. So what you're going to do, it fails, application fails. Now you're going to go back, right? Or you can look at here. Simply do debug. So if you do debug, I'm going to call that number, right? Call that method. Oh, we did step over. Step into. So now we pass num1 is 10, num2 is 8. So 8 plus 10 plus 8 is 18. So next line, we see that we pass the value correct, but on line 6 we see result total is 2. So something went wrong on this line 6. So now you're saying, oh, it should be a plus, not a minus, since it's addition. Then you fix it, right? So obviously it's going to return 2 is because this line not doing the right thing. Num1 plus num2 should be, but we left it minus num1 minus num2, that's why it returned 2. So we can fix this. So that's why the JUnit assertion is returning, hey, it fails because it didn't return the right value. So you're going to go back and fix that. Instead of minus, we'll say plus. So now if we run this test again, no problem, right? It passed. Or you can say some message here. Right. Something wrong. I'm going to throw the error. Okay. No. 18. right here. So if it passed, we can say test case is passed. But if it's something went wrong, we're expecting 19, but it's returning 18, then we see that it's returning, it's throwing the error, right? So we didn't hit that. So this didn't execute this because we skip that. Once you throw error, it's going to go catch and throw the error message. So if it's successful, it's going to execute this line, so you know test case is passed, right? So if we run this, see that since it's passed, now we're able to execute this. The message, hey, it passed. No error message now since it passed already. So this is how you can write unit testing. So you're saying maybe it's too obvious that add number, it should be plus, not a minus. What could go wrong? Why to write these test cases? So you just see one simple method. When you build a large application, you have few hundreds of classes, few thousands of methods, and to keep track, and a lot of people are working in the same, for one application. This unit test prevents a lot of bugs. It's really helpful. So this is mandatory in Agile environment that developer write some features, you must write unit testing. Some companies don't follow, some companies do very strict about it. So unit test can prevent a lot of bugs. So this, it fails. Now, so in the UI level, the QA has to catch it, right? But developer, if write unit test, they can prevent a lot of bugs.
Is it only done by developers?
No, automation engineer can also write unit testing, but mostly done by developers who are responsible for the features. So you assign a developer, hey, you're going to build the calculator features. So you're going to have add, subtract, multiply, divisions, all the methods you hear. Then make sure you write unit testing for all these features. So once your code check into the repository, it runs all the unit tests. So if anything goes wrong, it fails in Jenkins and send a message, hey, your commit failed. So you don't want to check in your code if failing code. So you're going to go back and fix your code. Then once it passed all the test cases, then you check in. So now, as an automation engineer, you'll be using this JUnit framework or TestNG to run our test, to verify our test, to control our test. So we'll be exploring JUnit and TestNG a lot. So this is the API you'll be spending time from now on. And TestNG API is this. Okay, so we must get familiar with this before we start Selenium. Any questions on this? So you can also write JUnit test cases from here. If you don't use the main method, simply you're going to use testing framework without main method, which is JUnit has, TestNG has part of that, their class. So you can say simply here, JUnit test cases. And then you'll say setup method, setup before class, tear down, and also test JUnit, right? So you say setup and tear down, finish. it goes by annotation. So this JUnit test ng method don't need to have any main method because the framework has part of the main method. You don't have to worry about that. So set up some test here, and then do some test here, and clean up those test cases. So this is what you'll be using when you start Selenium. All right. Now just get familiar with the test engine JUnit after the exam. In the exam, we might use some unit test. Depend. Let's see. If not, then just going to use for once it's to Selenium. All right. So we'll go back to some of the part of data structure. So everyone okay with the sorting algorithms, right? It's going to be part of the exam tomorrow. All different kind of sorting. So now, tree graph is not going to be part of the exam. The rest of the data structure will be. But simply going to go over tree. So tree is a non-linear data structure. Why do you need tree? We already learned array list, linked list. Right? Why do you need tree? So you saw if we have a linked list, if you have an array list, this is array list. If you have a linked list, this is how linked list work. Each node is connected to one to another, right? Fine. If we have is numbers, right? If you have numbers which is unsorted, so think two options we have, either array list, which is the top one, and second one is linked list. So you want to search for a number, this is unsorted maybe, let's say, right? Well, it has to be sorted. If it's not sorted, then it's a problem. We can make tree. So if you are looking for a number called give me a number, large number, out of 1 million. Looking for a number maybe 488, right? Or 500. So now out of 1 million index, if you have to look for that, how you do? You do search from, starting from 0 index to the last index, which is starting from 0 index to the millionth index, because you have 1 million data onto the array, or 1 million data into the linked list. Now you're looking for that number 485, let's say, it's a random number. 485, well, in that case, you can search for after 485 search if you go linear, but now, let's give a bigger number. Let's say you want to search for 485,000 given number. So out of 1 million, you're looking for a number 485,000.
That means you know that they're all sorted.
It's sorted, yeah. If it's sorted, now looking for a number, how many operations you have to do to search for the number from a sorted array list? How many search? One to 485,000 search, right? You have 1 million. So if you have, Facebook has 1 billion users close to, isn't it? They have close to 1 billion users. So out of 1 billion users, if you have to search for a number, the maybe so 1,000 million is 1 billion. So you're looking for a number, maybe 800 something thousands. So it's going to be a lot of search. And by the time to return the result, it might be a few hours, few days for a machine to do it. If you're simply doing array list or linked list. But there's a better way to do, which is if you sort it, we're saying the number you're looking for is 485,000. Fine, this is the number you're looking for. Your lower bound is 0, and this is your upper bound, which is 1 million. So 100,000, right? This is 1 million, right? So starting from 0 to 1 million, you're looking for a number called 485,000. So if you are in a linear search, which is in array list or array or linked list, you have to do from 0 to up to this point, whatever 485,000 is. So that many number of search you have to operation you have to do. So it's a lot of operation for CPU. Same way in linked list, you have to do that search. So now, the better way to do it is if we use tree, it's a non-linear data structure. So what you do is cut by half. So if you have 1 million data into the array list and you cut by half, that becomes 500,000 here, right? Right? So its lower bound is 500,000, upper bound is have 500,000. So this is like 0 to 500,000. 500, 1, 2, 3,000. This is the middle point, right? And this is 500,000 to 1 million. This is the upper bound, this is the lower bound. So then you're comparing this target number that you're looking for, 485. You say, hey, is this number smaller or greater than 500,000? Huh? Less than. If it's less than, so it's going to be within this lower bound, right? So we can ignore this rest of the half. Then, okay, it's less than, but this is not the number we're looking for, 500,000, but it's 485,000. So, okay, we have to do compare again, which is cut in half here somewhere. Maybe here, right? Why it's not giving me that? So if you make half of this 500,000, it's make 250,000, right? 250,000 to 3. Now, is 485,000 less than or greater than? Greater than? Greater than, right?
Yeah.
So it's going to be on this range. So you can ignore this lower bound now. Alright? But this is not the number we're looking for, right? It's looking for 485,000. Fine. So now between this bound, can we make it a half? We can make this half. If we make this half, we get what is the number going to be? 375,000. Okay. Fine. So now if compare this 485,000 looking for to this, and say no, it's going to be greater than this, so it's going to be in the upper bound, not in the lower bound. So you're searching to the right. So it goes to this way, right? Fine. Then again, you cut in half. Then it's going to be around 400 something?
Yeah.
Four to five pounds. No, well, that way there are chances you will end up with more search. I'll tell you why. So right now, let's finish up this. So now we cut in half, and it's around 400 something. And someone can do the math. So 375 to 5,000. The middle point is 437, right?
Yeah. 437.
Okay. So now, comparing this to with this, which is it's still greater than this, so it's going to be here, somewhere here. And out of this, it's going to be around 470, around that?
468.
468, okay? 46875. Okay, fine. And it's going to be up, it's going to be on this bound because it's greater than this. So you're going to make half again. At one point, you'll see 480 rent or 85 rent. Okay? So, so it's going to be in that range, fine. And again, we look for this number. It's pretty close, we're getting pretty close.
That's 44.
484, okay. Maybe after 2 or 3 or 5 more, we'll get this number. Right? So now we see how many operations we did. First we did here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 max maybe. Or 12 search. We get that number. So we're looking for a number for 85,000. Out of 1 million, maybe 12 or 15 search, we can get the number. But if we don't have this way to do it, then you have to start from 0 to the target number, which is 485,000 operation. See how much time we are reducing?
But this won't really work on back to doing data that's not sorted at all. Arbitrarily thrown in there.
No, we have to sort it out.
Yeah,
So once you get the data, we sort it out, and then you apply these 3 operations. She was saying, can you just simply do, why do you have to go to halfway? Why not like look for 400 range? It's because you don't know what, this start from 0 or 1. 400,000 could be anywhere. So it's safe if you do halfway. Take a few more, but you're not losing it. If it's not within this range, it might be there, other range. And again, this number is not like, so you have 1 million data. Now, it's not like it started from 0 to 1 million. It could be, data could be any range. Maybe it could be start from 100,000 or 300,000, it could start from. And the data could be, we're saying 1 million, not 1 million up to. It's a 1 million data. Think about 1 million data. And the data, starting from maybe, it could be in different range. So it's better to search from cut in middle instead of ranging yourself. So tree is really helpful if you have large data set and you want to cut by 2 every time and compare with that number, and you can cut half either by lower bound or upper bound. So it really, in terms of searching, binary search tree are really great, that it can quickly give you that numbers you're looking for. This is about tree. We're not going to use tree, but simply go over what tree can do. If you're interested to explore more, data structure book, please read that book. It will be helpful if you keep reading it.
This is the most efficient way to search.
Uh,
Or are there like more?
there's a different kind of search too. Like in tree, there's different sections.
This is really larger set.
Legislative data. Yeah. In terms of graph, do you need graph though? All right. So this could be graph look like. This could be map of United States, right? So now, if you are here, um, Seattle, right? This is NYC. This is maybe um, Los Angeles, right? Phoenix. Vegas. Uh, Miami. Detroit. Could be. What's that? Today? North Dakota. Some city in North Dakota. And this is Wyoming. Colorado. Austin, Texas. This could be Little Rock in Arkansas. Okay. So now, if you are in aviation industry, right, you need a map for the pilot to go from one city to another city. So you have a route to take. That hey, you can have to stop by one of the cities or airports. So graph really helps them out to navigate. GPS, one of them, that helps to navigate using the graph. Also Facebook search, it helps to find your friends. So we'll discuss that too, which might be here. So now you have a friend here, right? So this is you, right? This is Furkan. He has a friend, uh, maybe your friend name? Huh?
FAI.
FAI? Faizan, okay. And Faizan has a friend called Chaudhary, right? Abram Chaudhary, right? And he has a friend of Abdul Khan. So now, see that when Furkan and Faizan are friends, sometimes Furkan does receive notification or some message, hey, you may want to add Abraham Chaudhary or Abdul Khan, is because they are a friend of your friend, right? See that how they make a connection? It's because they're using graph, right? Since you are Furkan is friend of Faizan, and Furkan can receive message about Abraham Chaudhary, hey, you may want to add him. Or you may have some connection by, he may live in your neighborhood, right? Then you say, okay, Furkan has some friend, Miyad, probably live in the same neighborhood. Then you get notification of Abdul Khan that you may want to add him. So this is all about using graph algorithms. So same here in terms of navigating for the pilot to which route to take. So they want to optimize some flight is going from JFK to Seattle. Then you have option to take all the way to the north, or all the way to the middle, or all the way to the east coast, or well south, right? So you can take. So it depends on how you outline. So how many miles here? So maybe 5, and you have 6, 7, 3, 4, 2, 9, 3, 2, 5, 6, 3, 5, 7, so on. So you have weighted graph that if you want to travel, take either route, right? You have multiple routes to take. If you take all the way to north, which is following this, right? You have to pay, like, you have to drive probably 5, 6, 11, 18, 21 nautical miles maybe. Now, if you take this route, you have to take 2, 4, 6, 6, 7 is 13, 13 and 4 is 17. So 17 nautical miles you have to fly if you take this route. If you take other route, which is this, so 9, 3 is 12, 14, 20, 23. So you have a 21, then 18, was it? Middle one? And this is 23. So they optimize it. If somehow, even though optimized road is busy, right, you have to wait, then they can reroute to other route to take. You may have to take extra nautical miles, but still better. Same way, when Google GPS optimize your road, okay, to drive from point A to point B, you can go by 5 miles. The distance is 5 miles, and the route you have, straight line, it has so much traffic, some congestion there, some accident there. So they're going to reroute you in different way to take, even though it might longer in terms of driving distance will be longer, but you don't have to sit in the traffic, right? Because there's no traffic, other road. You might drive another extra mile, but still you can save time. This is how Google Map is helping out to optimize your route. Getting updates from the traffic, right? How do you get all the data that there's a congestion going on or some traffic going on? How? If because all the users have cell phone. Anybody drive car has probably cell phone. Mostly they have cell phone. So number of cell phones in that road, right? Kind of optimize. Hey, it's probably some rush hour there, some traffic is there. Also, now Waze, the app, they report, hey, there is some accident going on. Right? They have different sources of data to receive. Once they receive those data, then they give suggestions to you, hey, you may want to take this route or other routes. So they are using map also for that. In terms of another way to do it, when you hit the Facebook server, right? Someone in New York using Facebook, it may hit the server if they have an East Coast or all the way to the West Coast in Oregon. Fine. If someone else sends a request from Europe or Asia, where that request should go to? Facebook also have server in Europe. They also have server in Asia. So it optimizes the request it's coming from, they route to that closest locations they have. If you don't do that, then you have to travel all the way from Asia to here in Oregon or in California, whatever their server is. If somebody sent from Australia, they'll be looking for some within that region where the closest server is. Someone is sending a request from Japan, it's not going to come to the US. They will send some to the server they have within that region. Maybe Japan probably have their Facebook server, right? So it's all these server requests is coming. They are actually underlined. The code is graph that how the request should be routed to, where this request should go to which server, right? They have different locations of their on the world, and this graph algorithm will help them out to optimize the user request.
So the preference is time, it's not distance. Because if it takes you, like, if it's 5 miles from New York to Detroit, but it takes you a shorter period of time, if you use a different road, like let's say you go to Little Rock and then ND and then to Detroit, it takes you a lower amount of time. So you would take that road instead of like A to B, instead of New York to Detroit.
Yeah, so it depends how many miles it will fly, right? So you're saying Little Rock is 2, but down the road you might have more. So you're saying, okay, you have to go option from New York City to Detroit or Little Rock. Okay, it will go at Little Rock first. Fine. Before you fly, that algorithm will go Little Rock. Fine. Then it's going to go, okay, what are other options you have from Little Rock? Miami or Dakota or Colorado. It's going to go all the way to the end. Then it's going to optimize for you that we found the shortest distance for you.
No, I'm saying, like, you want to get to Detroit from New York, right? Are you going to take the direct path, just the 5 miles? I'm saying it's going to take you shorter amount of time to go to Little Rock and then to ND and then to Detroit. Which one would you take? It's going to take you shorter amount of time. It's going to be a shorter amount of time for you.
How? It's going to take more if you
No, I'm saying, like, let's say there's traffic in the 5 mile road.
This is the other thing. But for driving, of course, we are also talking about there's less condition in aviation. No, this is the aviation. But then we are talking about you're driving from here to Manhattan, right? Okay. Why is not doing what you want? Okay, so let's say you are here now, right? And you're going to go to Manhattan. You have the option to go take Queensbridge, right? Or Midtown Tunnel. Midtown Tunnel, you have to pay toll if you want to go. This is Manhattan. So now you're driving from here. You have an option to go either bridge, free toll, no tolls, or midtown tunnel, which is short distance, right? If you want to pay the toll, and which is Williamsburg Bridge. So now, if user choose, hey, I want to route without toll, so then the with toll is much shorter because it's direct. Without toll, you have two options. Either take Queens Bridge, right, or take Williamsburg Bridge. So now, if there's a traffic, in Queens Bridge look like shorter, but there's so much traffic. There's a delay of 20-minute delay on the bridge. So you may be better off taking Williamsburg Bridge. Even though it's long distance, but no congestion there. But you can get to the Manhattan quicker way. Yeah. No, that's what Google Map is offering. This is what Google Map is doing, right? So now what if you go, now your address is somewhere right after Queens Bridge, right? And it also think about it, oh, the address is next to the Queens Bridge, so no point to go all the way to Williamsburg, but let's route to him, take the bridge. If it's somewhere going in the middle of the Manhattan, Midtown, then either route can get you there quickly. So let's condition Williamsburg Bridge, show him to that, take this bridge, and come here. So it's all about GPS, or aviation industry, the flight routes, or server requests coming in. It's all underlying code is graph. You're searching for a friend, and this Facebook is suggesting you that this is a friend. It's all about graph algorithms. So data structure is very, very important. We're not going to use a graph, but just give you a brief how things work. What is the real applications you can think of using graphs and trees.
Facebook, and then like you said, it's Asia or tomorrow. So my server is the request is close to server or direct Japan or Asia. Not step by step, direct way to
No.
Direct,
No. So Facebook has data center or servers in different locations of the world. They probably have in Asia, they have in Europe, they also have in the United States, in multiple places. But mostly in Oregon, they have. So now, if the user is sending a request from here, I want to log into Facebook from Japan, look like the request don't need to come to here. They can reroute to somewhere in Asia, nearest location. Let's just, the nearest location is server down some reason, somehow. So it may send to Europe or United States server. If it's down, but it doesn't happen, they always it's up. So request comes in, they try to find the nearest server location. Wherever you locate it, they look for nearest server location, and you have same data, right? The server in Asia has similar user can log in, right? If you travel, so you're using Facebook here in New York, and you travel to Asia, somewhere country, and you send a request, that you've been using mostly the server here in the United States, but since you're traveling there, it's going to find, hey, this user sent a request from that location, so we can route to him nearest locations we have. Request doesn't come here to all the way here. It's first find the nearest location. Also, if the pilot is flying from New York to Seattle, and on the way he has some emergency, so maybe he's somewhere between Detroit and North Dakota, and he need to have emergency landing. Do you think he has to wait until Seattle come? No, he can send a request to the ground. Hey, I need to land immediately. Then they look for the nearest location, which is not only has to be international airport, but it could be some small private airport that you can land safely. So they have database there. Then they quickly find that nearest location of airport, and they give a signal, hey, maybe you want to use this airport to just for safe learning. All right, so this is all about just brief discussion about tree and graph. Again, you need to really spend time after the course end, try to elaborate more, read more data structure, problem solvings, try to learn more data structures problems, right? How to apply that, how to implement that, and that way you can do other things. Not only like testing, but slowly if you have options to become. So let's talk about this a little bit, since we have time. So web development may not need much data structure, right? Web development more depend. If you do front end, you need HTML, CSS, JavaScript. You can use React.js or AngularJS. In the back end, you can use Java or C# or Python or Ruby, PHP or Node.js for backend. Without knowing much of data structure, still you can build a website. But if the website is heavily data oriented, then you have to know much more about data structure. Data structure is very helpful when you're going to do design games, right? If you design game, data structure is very important. Okay. Algorithm trading also need data structure. Search, like Google search, right? Data structure is heavily involved there. Then if we design database, if we implement database, I mean design database like MySQL, Oracle, MongoDB, someone invented those, right? Those developers who develop database, data structure is heavily there. You send a query, it's find data for you. It's all about data structure. Like Oracle, they use heavily trees, right? So if you want to invent or develop database, data structure is like very important feature that you have to learn. Hash, trees. And if you are doing machine learning or artificial intelligence, right? These are the area you must learn data structure very well. Or data scientist, right? So if this is the area you are going to, if it's something that you're interested, right? You're going to learn or become AI engineer, data scientist, or machine learning expert, self-driving car, it's part of AI, right? So you must learn data structure. Security could be, but not. Security is more, I would say, like cyber security and other things. It's another good topics. Yeah, hackers, they're expert about hacking things, but you have to protect your. And security is like more, you have to know networking things, right? How networking works. So more about infrastructure setup. So now, after you've done the course, then you can maybe get a job as an automation engineer, right? Slowly, you want to maybe explore if you have interest that you want to learn, keep learning. You don't want to be obsolete after 10 years. You want to keep learning, after 5 years, new thing might come. Maybe you want to uh, explore one of those areas. This is fine, but in terms of data scientist or AI, you also have to have mathematics background, like calculus, linear algebra, differential calculus, right? Differential equations. These are the areas that need that background. But someone can learn. Khan Academy is there, learn free math. If you don't have mathematics, if you're not coming from that background like engineering or any math major you came from, if you're not, then you can simply take Khan Academy courses, learn those maths. And in the meantime, take machine learning courses and slowly become AI engineer. If you are AI expert, you can work for a company like Google for self-driving car, Uber self-driving car, Tesla self-driving car. They're hiring engineers, people who are expert in AI. So for these courses or for this area, data structure are very important. Without data structure, you cannot do anything there. So AI not in only driving car, AI in health, right? AI could be in many areas. Health. And self-driving. Robotics, right? So exploration, like Mars missions, they're going to use a lot of AI. So you don't want to be just of your life, just become automation engineer. Slowly, find your horizon at one of these things you can explore. You're young now; you can do anything to learn, right? So for this, you need background of coding. Everything is all about coding, right? And if you learn Java, slowly you can learn Python, other languages. And it's the same topics. Data structure, if you learn in Java, data structure, same concept in Python, same concept in Ruby, and every language is the same. So just learning data structure, learning coding is the important part. In any language you learn. Later on, you can apply, if you have to use in PHP or Ruby or Python, you can use that. Data scientists, they more use Python. All right, so this is the next, which is you should consider it, later on in your life. After working a few years in the industry as an automation engineer, then you figure out what field you want to pursue next. Mohammed Khan.
Yes, I have a suggestion. I'm not sure it's gonna work or are you gonna listen. But just you are a wonderful teacher. There's no doubt about it. But the course is like a 2.5 months, right? It's I believe 6 weeks, right? Not 6 week, 10 weeks, right?
10 weeks, yeah.
I don't know if you could, but next time if you could add 2 more extra week because there's a lot of things to learn, and you are teaching very well and everything, but it's so much to digest and so much to do and practice. I would say another 2 extra week will help the students.
Okay, yeah, the course is intensive, but these topics we're not covering anything.
No, I know that. I mean, basically, it's not only me. I got like a few calls from students from the same course this week and last week, and they were actually saying same thing. So I'm just trying to let you know what a lot of students feel about it.
Sure, we'll try to consider that. Uh, the problem is a lot of people are working now and they don't have enough time to do the homework.
Well, I get that, but I'm working too full time. But the thing is, you have to be serious. As I said, I mean, the gentleman who talked a couple of weeks ago, you have to be serious whatever you do. If you're not taking it serious, if you don't spend time, it's not going to come easily. Nothing comes easily.
Right.
So I mean, if you want to do it, you have to spend time. You have to practice. You have to try to learn. So
So,
it's basically it's all about how you want to do it. How seriously you take it.
yeah. I mean, we definitely, we've been thinking about it. 10 weeks may not be enough. How we can reshape or reorganize, adding more extra weeks may help people who need extra help. So we're thinking about it. Probably if it doesn't happen this semester, maybe we're trying to accommodate maybe next semester, right?
And that's all I wanted to just let you know, because as I said, it's nothing against you or anything. You were a wonderful. I mean, it's not I'm trying to make you happy or anything. You were a wonderful teacher. You have spent that much time, and you have a lot of patience and everything. But if we had another couple of weeks, I would say it would be very, very helpful for us. A lot of people don't have a programming background and all this.
Sure, we'll consider that. Thank you.
Yeah, thank you.
Yep. So one thing about materials that we're going to cover, and may not be that you'll get 100%. Even though if you get 60, 70%, still you'll be able to get a job. But see, the part of data structure we spend it here may not be directly useful at your job place right now, but something that we want to give you that later on, when you get a job or end of the course, you can carry on that what you introduce in the class. If I simply just limit that, hey, try to automate, try to learn simple core Java with certain limit and introduce Selenium API, and you will be able to automate some of the features of web applications. You can do the job, but we want to go beyond that. That, as I said, some of you are coming here from direct from school. That you graduate from school, either computer science or electrical or mechanicals, right? Some of you are from business background. So everyone has different expectations on the course. So we just don't want to leave you there that, hey, even though you get a six-figure salary job, but I want you to grow more in future. Whether just settle your life, making six-figure salary and be happy, that's one thing. The next thing is you need to keep learning things. You need to explore more. You need to pursue more in your life. This is your time that you're in the right field, that is growing, industry is growing, so you need to explore. That's why we're trying to open up your mind that not everything you can cover in the class, but rest you can at least take. So now you understood, maybe we did a couple of sorting algorithms, right? Rest I give you, okay, do it at home or do it group discussions. So that will cover pretty much all the sorting algorithms, right? I'll give you just one example. We didn't learn tree that much or graph, and just give it thoughts. What can you do with tree? What can you do with graph? Now it's your time, not during the course, but after the course end, you might have some free time that you can even explore that topics. That's what we're trying to do. It might be overall that, hey, the time, of course, the time, 10 weeks time is not enough. I totally understand that. But the thing is, also people who come here to take the course, they expect to get a job very soon. So we spent 6 weeks. First week, which is core course, which is SDLC and CNSS and MySQL's Jira, LM. 6 weeks taken by that core courses. After that, you come here for 10 weeks. The amount of things you're learning in 10 weeks, it's kind of, you have to be serious and be dedicated. And if you're working full time, it's become more even tough. So just go through the course, even though some of you join late, which is middle of the course if you join, do not worry to, I received emails about taking exam or not. Take the exam, even though you join middle of the course, it will help you. And You have to be, spending more time on doing homeworks that you missed. But do not give up. That's my concern, that if you give up now, say, wait for next course, you're wasting your time. So whatever you missed, you can cover, but keep learning, keep doing it. As I said, you don't have to learn 100% what you're doing in the class if you don't catch. Do while 50%, do while 60, 70%. That will put you in the job, and slowly you can explore. You know what to learn now. The important thing is, if you don't know what to know, you're never going to know. But if you know what to know, then you will learn if you work on it. Right? That's the important part. That if you know what are the areas that you can explore, if you know it, and if you're serious, you'll explore. But if you don't know that you have potential to do well in these areas, and something that interesting field are there, if you don't know, then it's hard to figure out. But if you know there is avenue that you can explore, it helps you, give you thoughts. When you have time, if you're serious, you can explore that and you succeed. So we'll consider that, extending more times. It may not happen this semester, but we'll try to do it the next one. For this semester, we can do what we can do. If we can finish on time, we can add some sessions maybe, right? But we'll try to manage everything we need to cover in this in the time frame. Questions? Anyone else? Okay. Okay, this is the right table actually I was looking for, to show you the difference between TestNG and JUnit. Annotation support by both, exception test is supported by both platforms, ignore test also, timeout test, suite test. Group test doesn't support by JUnit, but it's supported by TestNG. Now parameterized by object is supported by TestNG, doesn't support by JUnit. Dependency test support by TestNG, doesn't support by JUnit. This is the this is one of the interview questions. Could be. Take a note. I'll send the link. Okay, this is the link you can use. Another question came, how do you do database automation? Okay. For database, what do you want to do on database? That is, so you're looking for so you go to Amazon, right? Look for books. Now, automation engineer at Amazon, they want to test all the books categories if they are not. So it's coming from, of course, database and web services. So if you want to test this, hey, under this category, do we have these books? Right? Not only UI, but we also, all UI is coming from database, right? Or web services. So you can test this. So you can scrap it from UI by Selenium. But to connect to database, you can use JDBC, Java Database Connectivity, right? You can use that API to connect to database and send the queries that do you have this collection of books or they are not. Then you can verify with the UI side. that what Selenium is giving you from the UI, right? You compare that. So assert, expected, actual list of books. So you can use JDBC to connect to database, send the queries, retrieve the data, and then compare with the UI side. So we'll be doing JDBC to connect database, not for testing purpose, but more how to connect, how to develop or connect use JDBC to database, or Mongo API, right? MongoDB API to connect to MongoDB database. All right, we can explore one of them or both. Okay. So this is not part of Selenium. It's part of this is JDBC for database connectivity for MySQL and Oracle. You can use MongoDB. You can use to connect to MongoDB database. Once you learn one of these, then we have some idea how to do database testing. Questions? Anyone still need access for GitHub? Please let me know. The exam is going to be coding assignment and some conceptual, which is what you need in the quiz. Some theoretical questions and mostly coding problems. Coding problems in terms of core Java, that's what you learn, all the OP concept, right? Abstraction, encapsulation, inheritance, polymorphism, all the keywords you've been using, and conditional statements, switch case, enum. Some problem solving like finding prime numbers, right? Data structure could some algorithm design could be some problem will be given, find a solution using that random numbers, buffer readers. Also sorting algorithms must learn. Oh, but some XML problems will be given that give you part of the solution will be given. Just you have to figure it out yourself. We'll discuss that during the exam. Yeah, using database SQL Server. Mohammed Khan, you wrote, your company is hiring. Okay, sure. You located in where? In Chicago, you mentioned? Because we have few still looking for from last semester. So you can, forward the resume if you want to. Aman, I'm sorry. Aman? Okay, no. Mohammed Khan, if you want to send your resume, send some of the engineer's resume, you can do that to your company. Yes.
Just a FYI, because since if I can help someone, I'd love to.
Yep.
I'm in Chicago. I'm in my corporate headquarters. but we have an office in Dallas, Texas. We are hiring two automation engineer, and,
Sure.
and
May
I have very good relationship with my manager, who is the hiring manager.
great.
Matter of fact, she called me yesterday, so I could have, if I could have just talked to her and give the resume. If I can help anyone, I'll love to.
Sure, I appreciate that. Uh, what's the name of the company, if you don't mind?
Is one of the Fortune 500 company. I'm very sure you will know. Allstate Insurance.
Allstate Insurance. Good.
Yeah.
So, is it okay if I give your email or phone number to those who are interested?
I have no problem with that.
Okay, cool. So, I don't know which email I'll grab it from.
You should have my email address.
Yeah, should be here. You can grab it. This is right. Okay. That's in the Dropbox too. Is 269?
Yeah, that's one. Actually, I'll give one as the better, which is with my always with my phone too. So I'll write it down here.
Okay.
It's in the chat.
Yahoo account, right? Okay.
Yeah.
Thank you.
No problem.
I'll forward this to some of the previous session students who are still looking for a job.
Yeah.
Thank you.
Okay. Thanks.
Yeah. So a lot of questions are coming about.
Wherever you're located, so you could open it and I would be best to do oversight your user. Interview. And there's the individual student, and I would be wondering what is the issue function? So I go to get then I access to
So in terms of looping, right? We are going to use all different type of loops, for loop for each loop. Also, you must learn iterator, right? Iterator with while loop, right? That will be part of the exam. Anyone joined new today? I hear it on its first day. So raise your hand. Hussein, go ahead. MD Hussein. MD Hussein, your hand is up.
Can
Yes.
you hear me?
Yeah.
I tried to put some code on the Git folder, but it didn't go. Is it like it's not open yet, or it should be there? Is it like my
But
coding problem?
um, everyone, take lunch break. If you're doing from home, you can keep doing it. If not, just we'll be back at 12:40. Thank you.
if I push my project to the computer now and then use a different device, is it going to be a problem?
No, so that's why we have it out. It's very popular. We have must have heat on that machine.
Great. What's going on with this freaking snow? What's going on with this freaking snow?
Oh, yeah, no, I don't.
Yo, do you really solve with your phone for me?
If you are on this machine already, you were already logged in. Since you did it once already, right? Yeah, you're already logged in, unless you log in as another user. As long as you don't change it to global user like someone else. This, so yeah, so just type in git clone and, well, first go to idea. First go to idea. Yeah, for your idea project. CD, you can check where you are. PWD.